Good morning. Today we are going to go over some of the basic functions of dplyr, the R package dplyr, dplyr, which I use practically 100% of the time in my work. So this is a very common one. And we're going to talk about the functions select, filter, rename, and mutate. And dplyr does more than these four things, but for the purposes of this course, we're just going to keep it with those four. You'll notice that I have some variables in my environment window in the top right that are not relevant to this lecture, but I'm leaving them there because it's related to other work I'm doing and it took a very long time to load. So I would rather not have to recreate that. Okay, but it shouldn't get in the way of this lecture. Okay, so the first thing we want to do in line 1 is call the library dplyr. We want to read in our heart data that we've seen before, and you'll see that heart has 303 observations and 15 variables. Okay, and so the first thing I'm going to do is use the select function in dplyr to select 3 variables from the heart data set, and I'm going to assign that to a new data frame called heart3. And I'm going to select the variables age, sex, and diagnosis. Note that age and sex are capitalized and R is case sensitive, so you do have to use the capital letters or R will not recognize what you are asking it to do. Okay, so selecting from heart, age, sex, and diagnosis. I'll run that line. And then I'm using the function call names, which is going to return the names of the columns in the new variable, or the new data frame, I should say, heart3, and those are age, sex, and diagnosis. Okay, so that was successful. And that's how select works. You just tell it which of the variables you want to keep. Okay, now I'm going to move on to the function filter, and I'm going to create another data frame called heart older, because I'm interested in only filtering the observations where the age is greater than 50. Okay, so whereas select works on the columns, filter works on the rows. Okay, you can think of it that way. And so I want all the rows, all the observations where age is greater than 50. Okay, and I'm going to assign that to heart older. And again, so the syntax is filter, the name of the source, and the condition. So I'm going to run that, and heart older, we can see in the top right, has 209 observations and 3 variables. So we've gotten rid of about 1/3 of our total. I can use the summary function to see what our data looks like. And if we look at age, we see that the minimum is 51 and the maximum is 77. So we have successfully removed everyone 50 and younger from this data set. Okay, we can use filter to combine more than one condition. And so here in line 10, I'm creating a data frame called heart middle age, where I'm filtering from our original heart3, and I am looking for age greater than or equal to 45 and age less than 65. Okay, so I'm defining a range between 45 and 64. So if I run that line and run the summary, now we see age goes from a minimum of 45 to a maximum of 64. Success. Okay, so the AND operator in R is the ampersand, just like it is in regular English. Okay, I can also look for conditions that are defined by an OR statement, and the OR operator is less intuitive. It is what we call the pipe, which on many keyboards is directly beneath the backspace key. Okay, and so here I'm creating a data frame called heart young old, where I'm filtering on age is less than 40 or age is greater than 70. Okay, so I'm looking for the people who are either unusually young or unusually old in my data frame, in my data set. Okay, so I run that, and this time the summary is not going to tell me if I've done this successfully necessarily, because if I just look at the minimum and maximum, minimum 29, maximum 77, that doesn't tell me that I've successfully removed the ones in between. So I'm going to use a different function here called unique, and that's going to give me the unique values of Hart, Young, Old. And here with the $, I'm specifying that I'm only interested in the unique values for the age column rather than all the columns. And so it's not as friendly of a output here because it's not sorted or labeled or anything, but we can see, scanning this relatively short list, that every number in this output is either below 40 or above 70. Okay, so we have successfully accomplished a filtering based on an OR statement. If you want to filter on an exact value, you have to use, this is a little bit unintuitive, and it's one of the few places in R where you have to do it this way. You have to use a double equal sign, and that is just how the author of this function wrote it. There's some computer science theory behind why you would want to do this, but it's actually I make this mistake myself. I forget to remember to type 2 equal signs, and I only type 1. I'll show you what happens if you do that in just a second. First, I'm going to create a variable called, or a data frame called Hart65, which is filtering on ages exactly equal to 65. And if I look at the summary there, we see that the minimum and the maximum are both 65. So that worked. What happens if I use 1 equal sign? Because probably all of you will do this sooner or later. You get an error message. But unlike many of the error messages in R, this error message is actually understandable. It says age equals 65 must not be named. That's a little strangely worded, but do you need double equal sign? Okay, this is the helpful part. So it actually correctly anticipates what you did wrong and gives you a suggestion. Unfortunately, many of the errors in R are not as easy to understand. Okay, you can combine conditions across multiple variables. So here in line 20, I'm creating a new data frame called HeartX, which is a filter where age is exactly equal to 65, sex is exactly equal to 1, which represents males, and diagnosis is exactly equal to yes. So if I run line 20, and we see in the top right that HeartX only has 3 observations, right? So we've put some very strict conditions here, and we have almost no results. Age is exactly equal to 65, sex is exactly equal to 1, and diagnosis, because it's a character, the summary function does not give us very useful output there, but we know we could use the head function of HeartX, and here we see that all 3 of the data items are identical. Okay, now I'm going to move on to rename, the third of our 4 functions we're going to talk about today in dplyr. And with rename, you specify the data frame that you're renaming from. The new name equals, only 1 equal sign here, the new name equals the old name. And you can do this for multiple variables at once in a list form separated by commas. So here I am renaming in the original Hart data. I'm creating a new variable called pain, formerly known as chest underscore pain underscore type. I'm creating a new variable called sugar, formerly known as fasting underscore blood underscore sugar. Okay, and so you might want to do this when you want to do less typing, right? So if you have variable names that are very long like this and you find yourself typing them very often, you might want to come up with shorthand. Obviously, you want your shorthand to be understandable. If you just start using letters like X and Y and J, that becomes more difficult for an outside person who's looking at your code to understand it. But simple short words often can work. Okay, so if I run line 23 and I we look at the call names for our new data frame, we see that here we have pain, here we have sugar. So that was successful, and then we see that some of the other longer names are still maintained. Okay, and finally we are going to look at mutate. And mutate is what you do when you want to create a new variable based on some condition of an existing variable. So for example, this trivial example, but suppose we want to create a new variable to describe age in months instead of years. And so that simply is the original age times 12. Okay, so the syntax is mutate, original data frame, new variable name, and whatever mathematical operation or transformation you are applying to that data. Okay, so if we run line 26, and if we look at I'll use the head function here, and when you have a wide data frame with many variables, it scrolls them, and so you can see that it starts with age and sex and then scrolls them across several screens, and then finally at the very end, age and months is the one we created, and you can see that these numbers do represent the original ages multiplied by 12. Okay, thank you. That is all for dplyr.